Let me go ahead and share my screen. I have a few slides prepared, not to bore you to death, but give some background rather than just my picture. Can we see this now? Can we share this?
Yes.
Okay, that seems to be positive. That's great. So I'm the interim director of the Professional Master of Embedded and Cyber Physical Systems, which is a graduate degree program here at UCI. And I'd like to give you a brief overview of what we are doing and why we encourage you to find your future at UCI. This is the event name, and I like it because that's exactly what I would like to talk about. Again, my name is Rainer Dömer. I do have this funny character in my name, background in Germany. Don't worry about it. You can also type this with an O. It will work the same way. Let me go right into it. Why do you want to join UCI, and why in particular do you want to join MECPS program? So find your future at UCI. Why UCI even? I have a few arguments for you, and this is arguments not just by me. They're all over the campus. They're posted there. We have flags on the flagpoles, and they look like this. We are indeed the #1 college, according to Money magazine. And there's more. UCI is also a top public university, according to US News and World Report. So it's not just a small magazine that says this, it is something significant. We are also the #1 American Dream University, as per the New York Times, that is there. And we are #1 public university as well for Forbes Best Value in Colleges report. And there's more. I still have 4 more flags to come. Let's look at them. We are also the #1 cool school according to in the US, according to Sierra magazine. And cool school means environment and all kinds of other things, but that's us at UCI here. We also have a good sports department. We won 28 NCAA national titles. We are a top 10 hospital in California, according to US News and World Report. And last but not least, for this purpose here, the future is bright, make it brilliant. This is what UCI is for you. So you can find your future here, and we will try to make it as bright and as brilliant as we can do. That's about UCI. Now, what about MECPS? This long and awkward acronym is not the most marketing style, but it is the truth. We are representing the professional master's degree of embedded and cyber physical systems. The keyword that you may want to remember is not even in the title, it's computers. We are dealing with computers that do not look like computers. We call them actually embedded computer systems. So those computers that you find in your car, in your cell phone, in an airplane, those are computers that are of our interest. And we're dealing with these computers in the context of cyber physical world, meaning in the real world where these systems are being embedded into it. So the program is all about the intersection of computer hardware, computer software, and IoT, the Internet of Things, where there's billions of devices being connected to the internet. They're networked, they're talking to each other, and they contain hardware and software and need engineers to deal with this. It's a full-time graduate program lasting 4 quarters, including plus a summer quarter in between. So we have 5 quarters in total. And you will take 11 courses with us, with lectures and discussion sessions, with instructors, with teaching assistants and laboratories. And some of these titles of our courses are listed here. I get back to that in a separate slide later in more details. But there's only 11 courses, so you take 3 courses in every quarter, and you graduate within 4 quarters plus the summer. There's a final capstone project as well. That means we are putting all the knowledge that is accumulated in these courses together, and you build your specific project in a small team setting where you actually take one of these application areas for MECPS, for the cyber physical world, and build a system, a prototype for it. That might be in an automotive context, it might be for transportation, it might be in avionics, airplanes, or drones, or whatever comes to mind. And you can mostly freely choose this project application. In the end, you just want to build a prototype for it, demonstrate that it actually works, and that it would be feasible to do. So it's a project-based conclusion of this program. Most of all, it is career-driven. We want this program to be taken by students who are career-driven, who want to join the professional workforce soon after their bachelor degree. They take a short MS professional degree with us, and they can then go and apply jobs in the workforce and work for all the exciting companies in the world. Embedded and cyber physical systems, you might still think, what is that? Let's look at this. We can put a couple of pictures on the screen. They show up in healthcare. So around your cell phone with images, for medical images, for all kinds of options. They pop up in transportation. Every car nowadays has multiple processors, many processors actually, and they do all kinds of smart and clever things. Somebody needs to design this. This is what we are training students to do. There's other systems like bridges, there's homeland security, there's energy, there's the aerospace. We can help there. We also look at sustainability in the environment. Our systems can help a lot there, can monitor, can sensor data, and help us evaluate data in that context. There's manufacturing jobs out there. There's a smart home application. So when you're setting your thermostat up a degree, nowadays that's automated, and there's systems behind it that we call embedded systems. So an embedded systems is actually the computer that is behind all these applications. Actually, it's not only one, it's typically many computers that collaboratively solve the problem in any of these devices by use of signal processing, by use of control applications, by use of sensors and networking with the internet infra, and all the other technical terms that we have. That's what concerns us in this program. And why do you want to join MECPS at UCI? First of all, we are quite unique worldwide. And most of all, this is the place where these systems get born. The Center of Embedded Cyber Physical Systems is an organized research unit here on the UCI campus for over 20 years now, and it is carried by the schools of engineering and the School of Information and Computer Science faculty in these schools. There's a center where these faculty collaborate, and everybody in this center is an embedded systems engineer, is a cyber physical engineer, and so on. I will put some names here just for reference. Most famous one is Professor Daniel Geiski, who actually founded the Center of Embedded and Cyber Physical Systems, where this is coming together. And he did his research there, he contributed, he defined and coined the term of embedded computers, and that's the authority worldwide. There's my colleague Fadid Kodahi, and then there's myself. We are serving as the interim director and the director of the center at this point, but we are not alone. There's an executive committee with famous professors, and there's actually 25 plus professors. I don't want to bore you with these names that actually carry this program. And since we are all doing research in the same field, we can apply it directly in this program, and you get it firsthand and not only via some stale book information. Here's another slide that should be exciting. Cyber physical systems can be just seen as a different name for the Internet of Things. And if you Google the Internet of Things, you will see that that's everywhere around us. So there's a lot of business here. I don't want to explain the entire slide, but there's many devices out there. They're embedded in the real world. They have sensors to measure something, and they will react to these measurements. The cloud computing is integrated. Many of these systems and services that are provided happening in the computer cloud in some data centers. And then the information gets back to you or just the device, and it makes smart choices by itself. So IoT, Internet of Things, is nothing else but cyber physical systems. They can be used interchangeably. Here's another slide with exciting technology there. So we are dealing with all these computers that are not looking like computers. They're hidden in these devices. They're hidden in telecommunication systems. They're hidden in the automotive systems, in the cars. Many devices are there. They're in the robotics. They are in measurement devices, scientific computing, and everywhere around it. I don't want to go into more details, but this should be exciting. This is a chart not taken by us. This is coming from data straight from resources that research this. And this is the number of IoT devices that are expected to be in this world. There's historical data, and then there is future projected data. And you can see this exponential curve going up. 75 billion devices are expected to be there in a short time. And those need to be connected. They need to be built. They need to be reliable. They need to be low power and so on. So there's a lot of engineering effort necessary to keep these things working and to build them. And that's what we train students for the workforce. Here's a brief overview about the curriculum in the current year. Curriculum is always being re-evaluated. We're improving on it, but this is the current status. You're joining us in the fall quarter, take 3 courses. You then take the winter, take another 3 courses, and the spring quarter with 3 courses in different framers, one of which is a case studies course where you actually go into your chosen application area of your interest. That might be health, that might be medical, that might be just robotics. Anything is the choice here. Then in the summer, there's an opportunity for internships, and the second fall quarter, you will be graduating at the end of that. You will do your CPS project course in that sense. That's a capstone course where you apply everything you has been done to a prototype, build a system that is exciting, and show it off at our career fair and our symposium that's always at the end of the fall quarter. We also include the entrepreneurship course, so you know how to behave in the professional workforce, inside big companies, outside of new companies, possibly become even a starting member of a startup company. Here's the same information in textual information. I don't want to go over and read these slides there in terms of which course numbers contain to which title, but you see that everything is there that concerns these systems, including machine learning and data mining, the hot topics of these days. Now I have the career services slides, and I may want to hand it up over here for Nikki, who is working with a team who takes care of professional career support. Nikki, can you talk about these things?
Yes, thank you. So one unique factor to this program is that it has a dedicated career services center. So instead of many programs that use the general campus-based career services, you have a person who is completely dedicated to helping you build your resources. And that starts day 1 within the program. Many students like to wait until the final quarter when they're looking for a job to start going through the process and attaining the skills. And then they get bombarded and stressed out at the end. So we have built into the program a dedicated career support. So starting in the fall quarter, you go through things like resume review, cover letter, interview prep, presentation skills, networking events, salary and contract negotiations. So sprinkled throughout the whole program, you would get all these skills. And this really allows you to not only leverage your degree to get your next job opportunity, but really gives you a toolbox full of necessary tools to get every job from now until you retire. So other things that are included in this is we have self-assessments over the summer to kind of see where you are and starting out, and a little self-exploration. There are career fairs pretty much every quarter, and we do site visits and industry speakers. So we have very strong connections within industry, and this is an opportunity to not only get a look inside these companies and corporations, but also work on your networking and start building your relationships. So when you enter the workforce, your network is strong.
Okay, let me unmute myself here. This is another slide. So thank you, Nikki, for the career services portion. I do not know why the ordering is like this. That was not intended on my slide deck, but this happens. That's okay. Where's UC Irvine? Well, I want to point out that this is actually the number reason why I personally came to the US and to California in particular. The weather is very nice here. We do have nice beaches for weekend use. During the week, we work hard. And on the weekend, we can do things. We have Disneyland nearby. We have Los Angeles, Hollywood, everything nearby. That's where University of California, Irvine is, where it never rains in Southern California, okay? And this is our campus. I just took a screenshot to show you how green our campus is. We have a nice park in the middle. So it's a really nice area with housing for students, for faculty. The central park is the one where all the institutes are located. And it's a nice area here in Orange County. This is the engineering squad where our courses take place, our research takes place, where our faculty work in these buildings. And I'm right in the center, sitting right now in my office in this engineering hall building, just for information that is there. Let me bring up this one slide, and I would like to hand it back to Nikki for this logistical speech.
So admission requirements for our program. We do require a bachelor's degree in either computer engineering, computer science, electrical engineering, or alike. If you have any questions about your undergraduate degree and its fit, please don't hesitate to reach out. We'd be more than happy to look at some of your coursework and your transcripts to make sure that you have a solid foundation to build upon. We do have a GPA of over 3.0 on a 4.0 scale requirement. And then you go online and there's an online application and a small application fee. That online application includes a statement of purpose. You can submit all of your university transcripts from all the schools that you've attended. Little note, you can submit and use unofficial transcripts for the application process and application for review. If you are admitted and decide to attend, that is when the university will ask for official transcripts. So for the application process, feel free to use unofficial transcripts. They do need to be in English though. We also have an English proficiency requirement for our international students. You can either take the TOEFL or the IELTS. If you did your undergraduate degree within the US or at an institution where it was completely done in English, you do not need to take either one of those tests. We also require 3 letters of recommendation.
Excellent. Thank you, Nikki. Let me add one thing to this thing. On the top, there's the condition of a bachelor's degree in computer engineering, computer science, or electrical engineering. We do also consider people from other disciplines. You do not strictly need to have a formal bachelor's degree in these areas. There's many people out there in the existing workforce or students from other disciplines who have acquired computing skills and so on a side. If you put these things into your statement of purpose, we will review them easily and clearly during the admissions process. There will be 3 faculty looking at these applications and we evaluate them. We do have students in the program that do not have these strictly requirements of bachelor's degrees, but they have acquired the skills on the side and they're doing well in this program. So please apply, and I would look forward to see you on campus soon. There's one more slide on this deck. This is a pointer to where you can find more information. There's our own program degree website. There's the website for the center itself, where our research is described. There's the International Center for those of you who might require visa assistance and conditions. And last but not least, there's an email address for us where you can get personal information if you have any concerns and questions. Please visit these websites and help yourself with the information there.